I'm real thrilled about this next panel, and we're going to bring them up now. And Nolan, you'll be in the lead. So please welcome Nolan Duskin, former state climatologist.
Who does this? Wow, I can't see you. Dirty glasses. Hello, there's an audience here. Do I have a slide I can put up here? I have a couple slides I want to begin with. Hello, oh, they're coming soon. Oh, it's right up there behind me. Okay, this is our Colorado Water Congress weather and climate moment that you've all been waiting for. I'm Nolan Duskin, former state climatologist, and I'm not going to hardly say anything other than show you a couple of my favorite slides that you've all come to love and appreciate. Here's what we expect. What are you looking at here? This is a map of... It's the United States, absolutely. Showing the colors, our average annual precipitation. That's what we're all sort of tuned to. You see the blues up in the high country of the Rocky Mountains, and mostly the reds in the valleys. But this is what we get, and for this graph, I'm always so grateful for Zach Schwalbe. Zach, are you in the room? There's Zach, who is now moved up to be our COAGMET network manager, but he created this beautiful graphic showing what we actually get. 120 some years of actual data, and that's why you water managers have to earn your keep. And with that, I want to introduce the first speaker of our session here this afternoon, who is known to many of you, especially those of you in the Ark Valley, Brian Bledsoe, who is, yep, that's the last one, who KKTV chief meteorologist for what, 13 years or so? 12, yeah. Okay, and who is, of course, a Colorado native, the Bledsoe name, a bit of a name in the state legislature as well, a graduate of UNC up in Greeley, enthusiastic about weather all your life. And as a TV meteorologist, you sort of expect somebody who's only going to be able to talk about the weather, but being a part of the Colorado Ag Roots, he's always known that the Ag people want and need a good forecast of the next day, the next week, but what do they also ask for? The next season and the next growing season. So he's also carved out a bit of a niche for himself, looking into the seasonal prediction, growing season forecasting, and that's really what we're going to have Brian talk to us about today. So Brian, take it away.
All right. Thank you, Nolan. Appreciate it. Thank you very much for having me here today. It's a pleasure to be with you all and share some of the things that I have to basically talk about this afternoon in terms of not only seasonal forecasting, but also in terms of just looking down the road and asking you or challenging you today if you are looking down the road. I've got a huge background in agriculture. I grew up very rural. I live city now, so I see the divisive nature between the two right now across the state in terms of water, politics, and many other things, and I try to bridge that gap as much as possible. So a few of the things that I want to share with you today include not only that, but how we can use weather going forward to make better decisions, because to be perfectly honest with you, I don't think we're doing a very good job of that when it comes to water. And I'm interested in maybe after this, when we go into the break, having you come up to me or me coming up to you and sharing some of those things, that just better ideas on how we can work better together so we can use the tools that we have to be better about doing these types of things. So what I'm going to do for you today is give you a long-range outlook and kind of just break things down, whether it's going to be drought, deluge, or normal, because we never see normal. Normal is too much and not enough. You add it together and you divide by 2, and it's something we never get. That's basically what normal is. And a few of the things that I want to show you today include why we may see some of these different things going forward. So if we can do that. Maybe this one will work. Maybe it'll work. don't think it's going.
Maybe the other one?
Yeah, I tried the other one, Kelly.
One of them was a backup.
Kelly, maybe you can help me.
you
There we
There
go.
you go.
All right, so things to think about. We're okay right now, but I really don't care about that. Because right now doesn't really matter. It's what's happening in the future. Multi-year drought will come. It's not a matter of if, it's a matter of when. And California is a great lesson. And California, in my opinion, has been doing a terrible job at this lately. Terrible. And I think many of you would agree. We are overextending ourselves when it comes to water supply, and the population boom along the Front Range has been pretty crazy. That is trickling down to Colorado Springs, and we ran a story not too long ago that suggested that Colorado Springs would be the biggest city in the state before too long. We've got water issues down there. We've had water issues down there for quite some time, and yes, we are stupid. We're really stupid when it comes to this stuff. It seems like it always takes a crisis or a catastrophe to make a point, and then we try to learn from that, and then sooner or later we forget about it. And in this type of economy right now where things are booming, good common sense talk in many cases is bad for business. Nobody wants to hear about those things because everything's good right now. So then there becomes a basic neglect toward planning. And what are you guys doing to prepare for these types of things going forward? Because I think if you haven't been preparing or you just started preparing, you're going to be very much behind the 8 ball. So let's look at the current status as far as precipitation. Percent of normal the past 30 days. There is an awful lot of brown on this map here, okay? An awful lot of brown. And that basically indicates drought or the development of drought in one way, shape, or form. The worst of it has obviously been down here in the typical Dust Bowl region, southeast Colorado, southwest Kansas, the Panhandle region. This little blip up here, that's the storm that happened last week that gave us a little bit of a boost. But that was mainly north of I-70 and went north and east of Colorado for the most part. This is the last 90 days, which is even in worse shape, not only locally but regionally. And when I start talking about drought, I don't care if your farmstead or your ranch is the only dry one around. That's just simply you being unlucky, all right? If your neighbor's getting moisture and you're getting moisture regionally, you are not in a drought. Drought looks a lot like this, regional, and that's when I start to become increasingly concerned about drought, when it becomes expansive like that and it really starts to creep. So that's the drought monitor. If you haven't seen that lately, that's kind of what it looked like last week. The new one came out today. I didn't have a chance to get into it, but I know probably this is a little bit less up here north of I-70 than what it was last week at this time. But really, the whole state, for the most part, is experiencing some sort of drought in whether it's abnormally dry, moderate, or even creeping up to severe. And it has been rapidly expanding for a while. We need more snow, there's no question about that. All of these little red and orange blips here across the whole western United States, folks, that is basically percent of average right here. And you're below 50% of average in many cases here across most of Colorado. The southwest down in the San Juans are obviously in really bad shape right now, versus you go up here to some of the northern Rockies, they're actually doing okay. But that's the northern Rockies, and we aren't in the northern Rockies. We're down here where we've been struggling as of late, and I don't necessarily see that changing a whole lot going forward, at least in the interim. So, for anybody that has seen me speak before, I'm a big ocean guy, and by that I'm saying the long-range forecasts and seasonal forecasts start with the oceans. And if you neglect to look at those and the patterns that they're in, you're just simply going to be behind the 8 ball. When it comes to that. So these are sea surface temperature anomalies right here. So where you are, there's Colorado, obviously US, here's South America. All of this blue and green right here is water temperature that is cooler than average, or just simply cooler than it should be right now. And for those of you that have heard about the La Nina episode that's been going on, that's what it looks like right there in terms of sea surface temperature anomalies. Another thing that I think gets a lot less publicity is this area right up here off the west coast of California and off the coast of the Baja. Typically, when you see contrasts in oceanic temperature anomalies like this, you will fuel a storm track in one way, shape, or form here across the western United States. Well, you've got a little bit of a contrast right there. You've got a little cold pool here, warm pool here, but that storm generator has been doing something like this. And this warmer than average water here off the west coast of the U.S. has essentially kind of acted as a storm roadblock because there's no gradient there. And with the lack of gradient, you really can't get these storms fueled up and to develop a little farther south and impact us here in the sweet spot, so to speak, through the Four Corners area, northern New Mexico, to really give us some good stuff. So before we even entertain the thought of our weather patterns changing for the better, we've got to do something about this right here. And these things don't change overnight. They just don't. So it's going to take a little bit of time. And who was I talking about? So it just takes one, right? Just takes one storm. Well, that's right. How many storms have we had? If you don't get that one, it doesn't matter. You know, it's pretty much as simple as that. So, taking it a step further, the Pacific has an oscillation that back and forth about every 20 to 30 years. It's called the Pacific Decadal Oscillation. When it's in a warm or a positive phase, many times we don't have to worry about anything here in Colorado. When it goes to a cool or a negative phase, that's when we run into problems. And I charted all this back. Let's go back one here. Charted all this back to 2005. I could take this back to the late 1800s if we wanted to, but I just wanted to show you basically the past 12 years here, because you can see where we ran from positive to negative. But for the most part, we really got in bad shape here, mid to late 10, 11, 12, 13. Who's from the Southeast Plains in here? Raise your hand. Ark Valley. I mean, the driest 3-year period on record in parts of the southeast Colorado. Not just by like a little bit, but by like quite a bit. And I don't think it's a coincidence that we were dealing with these negative numbers when the Pacific was in that cool state that we had problems. It doesn't necessarily mean everybody in the state was seeing problems, but it means a lot of us were during that time. Recently, we got a huge bump here in the Pacific warmth, basically from early 14 through 15, 16. We've come back down here, though, recently, and you could see those numbers tried to get back to neutral and even negative. They didn't have a whole lot of luck. For that reason alone, I'm kind of optimistic that we will break out of this pattern at some point. Because I'll tell you, if those numbers were negative, I'd be really pessimistic that we would not be only talking about regional drought, but we would also be talking about the onset of what might be a multi-year drought, not just for the plains, but also for the mountains. Fortunately, we at least have that going for us right now. This is kind of what it looks like by the map here. When your PDO or your Pacific Decadal Oscillation is warm or positive, that's what your ocean temperatures kind of look like in terms of anomalies. Warmth down the west coast, cool out here. The exact opposite over here on the left. This is when we really start to run into problems here on the left. And right now we don't have that. So again, trying to find a little bit of optimism. And I usually live just south of optimism, so it's tough even for me to do that. But if nothing else, we have that going for us. The Atlantic also has this working for it, a particular oscillation, okay? And it fluctuates on the same order. And I charted it all the way back to 05. And you can see it waxing and waning, kind of coming back and forth. And here recently, we've been down here in kind of neutral or maybe even slightly positive territory. Why am I showing you this? Well, for all my agricultural folks that I talk to, especially the younger ones that don't have a drought plan, I drive it home with this map right here. And basically, back in 2004, a really brilliant scientist named McCabe came up with this. It's in terms of drought frequency. So when you're looking at your Pacific and your Atlantic in the particular phases, you can kind of correlate which has higher than average drought frequency or lesser than average drought frequency. Where you're seeing the reds, that's where your drought frequency is enhanced. That's when your PDO was negative or your Pacific was cold. This is where your Atlantic was warm. And that's what got us in trouble back in about mid to late 2010. Fortunately, we broke out of that. We went through a period of time where we dealt with this right up here in the upper left, where the Pacific was warm. We had that big El Nino not that long ago, and the Atlantic was cool. Right now, we're kind of in limbo. But if you look at that slide right there, it sucks to live in Colorado. Because 75% of the time, we have some sort of drought frequency going on. That's a problem, especially when we are overextending ourselves in terms of not only water supply, but water usage. Nowhere in history have we had more people using more water. Are we being responsible with that? I don't know. It just depends on what you think. I don't think so, if you couldn't tell that already. Let's look and see what's going on with our El Nino, La Nina situation around here. This is also somewhat optimistic. So this chart's upper oceanic heat content out there in the Pacific, where I showed you where that La Nina was, okay? So last year, we were dealing with oceanic heat content that was getting a little bit of a bump up here in the positive territory. We didn't have any real problems, although some folks said it didn't really start snowing until March. Well, it didn't. Late March, it turned on. Started snowing in March. We had stuff in April, May. We got rain. The southeast plains were wet. Everybody was fat and happy, all right? And then late summer turned around and into the fall, and we fell off a cliff. That's what La Nina looks like. But the good news is here, there are some signs that I think that it has actually peaked. And you can see how we've been warming that temperature up here during the past month or so. And that's really evident with this thing right here. So I know this is an animation, and I just want you to wrap your mind around it just for a second. And what you're looking at here is oceanic depth here on the left, okay, from basically the surface down to 450 meters. And then you're going across the Pacific here from east to west. So over here on the west side of the Pacific, you had warmer than average water that's lurking just beneath the surface. Over here on the eastern Pacific, that blue right there, that's the cooler than average water. Look at what that warmer than average water is doing. It's undercutting that cooler than average water and steadily eroding the La Nina episode. That's a good thing. That's an excellent thing, really. Does that necessarily mean that there's an El Nino coming? No. It just simply means that we are weakening the signal that has kind of put us in the position that we are in. And if nothing else, that's something to at least be a little bit excited about. All right? This is also many, many different computer models over here on the right-hand side. All of those models are looking at the same thing, whether there's going to be an El Nino or a La Nina. Right now, everybody's in the same camp down here, suggesting this La Nina episode is going to continue for a while. -1, think of that as La Nina. 0, neutral. 1, El Nino. And all of these models steadily break down that La Nina episode, bring us back up here toward neutral, and some of them even bring us up there toward El Nino. But I will caution you with this. With these models, we are entering a period of time called the spring predictability barrier. That just simply means that they really don't have a great idea of what's going on going forward, down the line, quite a ways. But if you look at what's happening right now, you can kind of see that they're on the right track with eroding this thing as we go forward. So let's look at the next 45 days here. This is a model, European weekly model. Where you're seeing brown, that's bad. Where you're seeing green, that's good if you want moisture. All right? So not very optimistic out here for California and most of the West. Down here along Highway 50 south, Dust Bowl area, a lot of Texas. That's not a big surprise to me because we have to gradually change what's got us here in terms of the weather pattern and the forces that are governing the weather pattern, if you will. So I would expect our drought, at least for the southwest part of the state, southern part of the state, southeast plains, to continue a little while longer before we're going to get some relief. And everybody up here knows that if you live north I-70, you get all the moisture you want and you never see drought, right? That's the way it works? Yeah. That's what everybody in southeast Colorado thinks because it's the truth. Okay? You guys get infinitely more moisture up there, it seems like, and don't have to deal with as much drought as we do in the far south and the southeast part of the state. And that's just the way the weather pattern sets up, okay? So bottom line, that's kind of what the next 45 days looks like. If we look at a computer model here, the NMME, this is a North American multi-model ensemble. It's a run of 10 models. They look at the same thing, and they kind of take the mean of what they are forecasting and then spit out a forecast for you, okay? So this is what that is projecting for February. February, again, green is good, brown, not good. And you can see where it's doing the brown thing down here, New Mexico, Texas, southeast Colorado. A little bit of a blip up here. And I don't necessarily want you to look at this in terms of absolutes or just take it all the way to the bank, but use it as a roadmap and use it at least as some broad guidance, if you will, to show you where the most active part of the country is, which again is up in the northern Rockies and then dumping it in here into the upper Midwest and the Corn Belt. This is March. White essentially would mean average. Again, you know, whatever average is where you are. Okay, we rarely see average, so take that with a grain of salt. But with the drier than average conditions lurking here just to the east and southeast, I would still say the farther south and east you live, you got problems. The farther northwest you live, you'll be in a little bit better shape. This is April. Now, as somebody whose bloodlines come from agriculture, if we fail in March and we fail in April in terms of moisture, that is a huge problem. It's basically, it'll basically kill the winter wheat crop in that regard if we don't get any snow. Because the wind never blows in March and April in Colorado. So, you know, it's all good when that happens. But anyway, April doesn't look good, at least for this particular model. If we go to May, same story. And not just Colorado, but a large part of the West. That's June. This right here is the monsoon plume coming out of Mexico through Arizona. That's what the model is seeing right there. You can still see some issues down here not too far away from us. That's August. Seems to relax. At least the dry signal relaxes. Again, this is the remnants of the monsoon plume here, coming up out of Mexico through New Mexico. Let's look at another model here. I know this is terrible to look at, this particular map. I just wish they would get it better, but they're not. So it's the global plat. But anyway, you get the idea. There's Colorado right there. And you can see March, April, May don't look that great in terms of moisture around here. They just don't. So that's really two models, not two, actually 11, because we've got 10 in that other one that I just showed you. This one, 11, looking at the same thing that suggests March, April, May will be problematic for not only Colorado, but a large part of the West. This is June, July, August. A little better here. Okay, at least the dry signal kind of relaxed, and that's somewhat consistent with this La Nina breaking down. That's kind of what we would expect to happen during that time. And then if we go September, October, November, and you might be scratching your head like, what are you doing looking at September, October, November? You guys have no idea what's going to happen 3 hours from now. What are you doing? Well, somebody's got to do it. And you people are asking. So don't ask the question and then turn around and say we don't know what we're talking about. Okay? We'll just have that little deal if that works. But you get what I'm saying here is that I think really short term we could still have some pretty significant issues here in Colorado in terms of adding to the snowpack in the mountains and also benefiting agriculture on the eastern plains. And not just on the eastern plains, but even out on the western slope too. Here's another one. Now I want to caution you, this particular model is the slowest to degrade the La Nina episode going forward. So it hangs on to it a little bit longer than some of the other ones. And you can see what the result is. So this is its forecast for March. Again, green is good, brown is bad. Notice where the storm track is. Notice where the storm track is not. Down here across the southern tier. And for us to get good stuff here in Colorado in the month of March, we don't want anything from the north or northwest. We want something coming up from the south or the southwest. And if California's door is shut here, that makes it really tough for that to happen for us. That's what March looks like. That's what April looks like. Again, not a whole lot different from the other couple of models that I showed you just a little bit ago. The real problem here is California with its door being shut out there, because that does not allow any hope for us to get into an active pattern if that continues, versus the storm track being up here. Corn Belt, Midwest, Northeast, doing great. This is May. Same story. Storm track is north. June, not a whole lot better. July, there's your monsoon plume right there. So it looks like mountain areas, a little bit of relief, perhaps, during that time. Eastern plains, boy, might have to wait a little bit. Same thing in August. Again, favoring that monsoon plume farther west. That's September. And that's October. And again, September and October, I know we're a long ways out there. And for September and October's forecast to actually verify, there actually has to be some moisture put in the soil to eradicate this dryness that's taking place, because there is not a worse positive feedback mechanism in the atmosphere when it comes to weather or climate than drought. Every day that the soil stays dry, it heats up more that next day. Every day it heats up much more, it dries out. And then you mix the atmosphere up and you get the wind into play, and it just takes off a mind of its own. So again, it's crucial that if we want to break this pattern sooner than what the models are suggesting, we need snow cover east of the mountains very quickly. Otherwise, we're going to get in the windy season and it's going to be on. So my thoughts here. La Nina continues through the spring, but likely has peaked for the reasons that I've shared with you today. Okay? So if nothing else, that's at least, I think, behind us. Models are very unsure of that future ENSO, El Nino, or La Nina state, kind of which direction that we go. Do I think we will revert back to a La Nina episode? I do not, because the Pacific is still somewhat in a warm state. So again, another check mark. At least we have that going for us too. Neutral El Nino development doesn't guarantee immediate relief of drought, especially when it's regional. It takes time to break that down, as you folks know. Regional drought development will likely get worse before it gets better. This is especially true the farther south, west, and east you go. Areas farther north, I think, that are closer to that storm track will fare better. All of the storm that we had last week, okay? We had an inch of snow in Colorado Springs out of that. And Castle Rock had, I think, like 6 inches of snow. Areas out near Burlington, north towards Sterling, northwest Kansas, they did great. In fact, that storm may have saved that winter wheat crop up there for a lot of folks. Just that one. And the fact that the Pacific is not in a cold state, it does favor drought relaxation at some point. Now, when is the real key? Okay, it's one storm we get covered up and then we start to build on that. We can make that happen, okay? But it's just going to take some time for it to actually get here. I do a lot of forecasting for different entities, okay? Whether it's transportation, whether it's agriculture, whether it's energy. TV is just kind of my day job. But I think there's a lot to be done here with water that just simply isn't being done when it comes to weather. And for those of you that think that I'm pessimistic in terms of where we are headed as a state, don't get me wrong, the whole water plan thing, that's great. And I don't mean to offend anybody by that. But I'm looking at that from a 1,000-foot view, and I'm like, we have so much more work to do in terms of understanding. With this divide that's going on between rural and urban, are you serious? We aren't going to get anything done. A lot of times that has to quell before anything's going to really happen. In 2007, nobody thought the housing market was going to crash. Nobody. One guy bet against it. His name was Michael Burry. What do you think Michael Burry's investing in right now? Water. I don't think he's stupid or short-sighted or anything. And that water can be infrastructure, it can be policy, it can be water rights, what you do with your water. Again, there's a lot of things to be done with water that we're really only scratching the surface. And if we don't figure it out as a state in terms of policy or really looking ahead from a weather standpoint to plan for these types of things, we'll end up worse than California, in my opinion. Thank you for having me today.
We shall hold questions till the end. Next up is our new state climatologist, drum roll. Yes, Russ Schumacher, who comes to us from Colorado State University, an associate professor in our Department of Atmospheric Science, but he grew up in Minnesota. He attended Valparaiso University.
There he is. Yeah, there he is.
and is here to give he's learning about drought. He's learning on-the-job training, as did I 40 years ago. But he's already ahead of the game when it comes to big storms and heavy rain, and that might be what we hear from him about today. So take it away, Russ.
All right. Thanks. Is this the one that works here? All right. Well, thanks, Nolan. I appreciate the introduction, and I appreciate the invitation to be here at my first Colorado Water Congress. So I'm happy to get to meet so many people here today and share a little bit about our extreme precipitation in Colorado. Brian kind of set the stage with the current situation, and I will talk about that just a little bit, but mostly focus on some other things here that we have to think about here in our state. So first of all, I want to thank Nolan. Let's give Nolan a round of applause. That's Nolan. Many of you have probably seen this photo before. That's Nolan at the White House when they installed the CoCoRaHS gauge there. It might even be the same tie that he's wearing right now. I'm not sure. It is, yeah. He doesn't wear a tie very often. But it's obviously big shoes to step into, and Nolan has done great things with the Climate Center and made great relationships with so many of you here in this community, and I look forward to doing that with taking things forward. Brian showed most of this. I'll just touch on a couple things. He didn't go back even a little bit further. We can fondly look back at water year 2017, and it was actually not a bad water year. The Southeast Plains had plenty of precipitation, just a little bit dry on the west slope, and at the end of that water year, ending at the end of September, not a bad shape, just a little bit of drought in the western part of the state. But obviously, as he talked about in the last 3 months plus, things have only gotten a lot worse. The southwest part of the state has been, essentially no precipitation from October through December, more or less. They've had a little bit since then, but very bad shape there. And similarly in the Southeast Plains, record dry fall and starts to the water year. January has been, for much of the state, at least we're off to a better start there, but certainly not enough to make up those gaps, especially in the southwest part of the state. And you can see how dry it's been down in Arizona and New Mexico as well. But you've heard a lot about drought now, and we're in drought, and I think we're not looking great in terms of that, but we've already heard a lot about drought, and now I can sort of scare you with the other side of the equation to talk about floods, and we know that floods are a huge issue here in Colorado. That's sort of my background and research area, and a topic that I'm interested in sort of personally and professionally, and I'll talk a little bit about some things on that topic. So let's look back. Can we make that go? Can we make the movie go? Will it work? If I click forward? No. Can you make it go, Kelly?
Go, go, go.
It worked when we tried it earlier, but if not, it's not a huge deal. Well, you can imagine in your mind. This was a radar animation over that week of middle of September in 2013. Maybe it'll start going here, but if not, it's not a big deal. Obviously, in the weather world, we like to look at maps like this. We like to look at the radar both down at sort of our local scale, but also zooming out to the big picture of the state. And what happened in this period, you see even in this one static image that's up here, some of those storms starting to get going on the evening of the 10th of September. This grew into this much bigger circulation over the northern part of the state with huge rain amounts along the foothills, especially in Larimer, Boulder counties, and some out into Weld County, the big rain event near Fort Carson. And so we get this sense of all of these interconnected things going on, both on the local scale and sort of the statewide scale as far as the precipitation during this event. But of course, this is the most recent big flood, clearly in all of our memories. But there's much history of floods. But it's obviously big shoes to step into, and Nolan has done great things with the Climate Center and made great relationships with so many of you here in this community, and I look forward to doing that with taking things forward. Brian showed most of this. I'll just touch on a couple things. He didn't go back even a little bit further. We can fondly look back at water year 2017, and it was actually not a bad water year. The Southeast Plains had plenty of precipitation, just a little bit dry on the west slope, and at the end of that water year, ending at the end of September, not a bad shape, just a little bit of drought in the western part of the state. But obviously, as he talked about in the last 3 months plus, things have only gotten a lot worse. The southwest part of the state has been, essentially no precipitation from October through December, more or less. They've had a little bit since then, but very bad shape there. And similarly in the Southeast Plains, record dry fall and starts to the water year. January has been, for much of the state, at least we're off to a better start there, but certainly not enough to make up those gaps, especially in the southwest part of the state. And you can see how dry it's been down in Arizona and New Mexico as well. But you've heard a lot about drought now, and we're in drought, and I think we're not looking great in terms of that, but we've already heard a lot about drought, and now I can sort of scare you with the other side of the equation to talk about floods, and we know that floods are a huge issue here in Colorado. That's sort of my background and research area, and a topic that I'm interested in sort of personally and professionally, and I'll talk a little bit about some things on that topic. So let's look back. Can we make that go? Can we make the movie go? Will it work if I click forward? No. Can you make it go, Kelly?
Go, go, go.
It worked when we tried it earlier, but if not, it's not a huge deal. Well, you can imagine in your mind. This was a radar animation over that week of middle of September in 2013. Maybe it'll start going here, but if not, it's not a big deal. Obviously, in the weather world, we like to look at maps like this. We like to look at the radar both down at sort of our local scale, but also zooming out to the big picture of the state. And what happened in this period, you see even in this one static image that's up here, some of those storms starting to get going on the evening of the 10th of September. This grew into this much bigger circulation over the northern part of the state with huge rain amounts along the foothills, especially in Larimer, Boulder counties, and some out into Weld County, the big rain event near Fort Carson. And so we get this sense of all of these interconnected things going on, both on the local scale and sort of the statewide scale as far as the precipitation during this event. But of course, this is the most recent big flood, clearly in all of our memories. But there's much history of floods in Colorado. They're not new. This is one of the well-known or at least most impactful floods in Colorado, but way back in 1921 on the Arkansas River, about 12 inches of rain at Pueblo and Penrose, and this was a huge disaster in Pueblo. There was, of course, the 1965 flood in Denver and surrounding areas, the Big Thompson flood, the Fort Collins flood, and the list goes on and on. And so I'll talk a little bit about kind of what we look at when we're trying to understand floods, and this is a really complicated equation here. This is probably the simplest equation I ever show in my classes, but it's a very important equation for understanding heavy precipitation. So the P here is the total precipitation, how much fills up in your rain gauge. The R with the bar over here is the rain rate that you had over the course of that event, and then the D is the duration, how long it rains. So the most rain falls where it rains the hardest for the longest. So it doesn't sound like a complicated concept, but it's something we always have to keep in mind when we're thinking about this. And so this is basically the first law of forecasting precipitation, is to keep this in mind. And so these two factors then, you can break them down a little bit further. So how do you get a high rain rate? How do you get it to rain really hard? Well, you need moist air, and you need it to go up. And in Colorado, we have this mountain range right in the middle, and also some smaller terrain features, the Palmer Divide, the Cheyenne Ridge to the north. Those are good ways to get, if we can get the moisture into the area, those are good ways to get that moist air going up, and some of our biggest floods have come from that scenario, forcing that moist air up the either the Front Range or other topographic features. But of course, out on the plains, we don't have mountains out there, but we can get big thunderstorms out there too that can produce very heavy rainfall. So as an example, here's this is kind of the classic example of this upslope flow producing a really big rainstorm is the Big Thompson storm, the end of July 1976. And so this is kind of a vertical cross section here. You've got that moist air coming in from the east, coming up the Front Range there, and producing this massive thunderstorm over the foothills and the mountains with fairly weak winds aloft, and so that we're kind of continually pumping in moisture at the low levels. The upper level part of the storm isn't moving very much, and so that storm can just sit there for hours and produce this deadly disaster. We can get the same sort of thing happening out on the plains. It's just that now it's not a mountain that's doing this, it's the storm itself. So the warm moist air goes up and it starts to rain, and then that produces cool air that sinks and flows away from the storm. But if that outflow stays close to the storm, that kind of serves as its own lifting mechanism. You keep producing new storms in that spot, and so you can get this kind of thing to repeatedly grow and produce heavy rainfall, even if you don't have a mountain range there. And so this is the sort of thing that happens out on the eastern plains. So I think one concept that's probably familiar to a lot of folks here in this audience, and even if it's not something you deal with on a daily basis, it's something you've heard about, this concept of the 50-year rainfall or 100-year rainfall or whatever it might be. And so this is something that it's certainly gotten a lot more attention in sort of the media and whatnot. We've started using these phrases a lot lately, and it's good to kind of think about what they actually mean, because those terms can be a bit misleading. So essentially, the way these numbers the way we come up with these numbers is you make a plot that looks something like this. So each black dot on here this is from a weather station. This is just an example. It's a station from Florida, but you could do this for any weather stations in Colorado. You sort of plot on here all of your data that you have. So all those black dots on there are the rainfall data from your weather station. And then you use some statistical methods to put some curves on there, to kind of try to match that data as you go from the common events down here in the lower left. These are the sort of everyday kind of or every month sort of thunderstorms, up to the really heavy events up here in the upper right, and that's where you can see all these statistical lines start to go apart. So when you start getting to the right side of that graphic, the 0.1, so the 10% probability on there, so that'd be a 10-year rain event or a 100-year rain event or a 1,000-year rain event. Obviously, the uncertainty grows as you get out there to the right. Those different colors are a lot farther apart. But we can actually have a fairly good idea of this, what a 50-year rainstorm or a 100-year rainstorm looks like if we have a decent record at a station. And so what these really represent, of course, is a probability that amount of rain might fall in a given year. And so when we say it's a 10-year rain event, it just means on average it'll occur that often, but it doesn't necessarily mean that it will only occur, if it occurs once, it's not going to occur for another 10 years. And this is kind of a way to hopefully try to illustrate that. Oh, first, here's what one of those maps looks like for Colorado. This is what a 25-year rainfall looks like for Colorado based on the data from NOAA. You can't see all the details in here, but the green colors are higher values, the browns are lower. So out on the plains, it maybe gets up to 4.5 inches, along the urban corridor, 3.5, 4 inches, out in the mountains, more in the 2 inches. So this is 1.5 to 2 inches. So this is, again, on average, this is a storm that has a 4% chance of happening in any given year. So have there been any changes to what these values look like? Obviously, everything there assumes that you've got a nice long data record and that the underlying data record isn't changing. we have seen changes to those values, especially in the central U.S. and the eastern U.S. over the last 50 to 60 years, where the 20-year rain event is now wetter than it used to be, or what used to be a 20-year rain event is maybe now a 10 or 15-year rain event. But in Colorado, those colors are not, so the blue colors are where it's gotten wetter. Over Colorado, it's kind of a mixed bag. There's actually not a very strong trend in these heavy precipitation events over Colorado for kind of reasons that we may not totally understand yet, but it's a bit different of a trend here in Colorado than what we've seen over the rest of the country. But I think the thing to keep in mind here is what some of these things mean and how often we actually can expect these to occur. So let's do just a little thought experiment here, and just imagine in a given year we got all the 100-year rain events that we'd expect. There's a 1% chance at each point in Colorado of this kind of storm occurring in any given year, and then we just map that out over the state, and we assume that we actually know pretty well what that looks like. And so this is after 1 year. All those little dots on there, maybe they're a little hard to see in the back, but the little dots on there, each one of those is a 100-year rainstorm, just randomly distributed around the state. After 1 year, there's 263 of them. So sort of on average, we should actually expect at your weather station, there's not a very good chance of it occurring. But if you take all the weather stations around the state, you actually should expect to see a lot of these in a given year. So we shouldn't be that surprised when these big rainstorms occur. So that's after 1 year. Here's after 2 years. I'll just kind of step through here. 5 years, 10 years, 15, 20, 25, 30. That's how many 100-year rainstorms we'd expect in 30 years. It's, I forget, over the whole country, it's like 120,000. I forget exactly the number over Colorado. But it's 26% of the state will have seen one of these in a 30-year period. The reason sometimes we use 30 years is, right, that's the typical length of a mortgage on your house. And this is saying that in the length of your mortgage, you've got basically a 1 in 4 chance that you're going to see a 100-year rainstorm. So it sounds super rare when you say this is something that only happens once in every 100 years. But at your spot, it's actually, when you kind of accumulate over time, it's actually a fairly high chance. So this is maybe a good reason to think about, whether to consider that flood insurance if you're in a place that is prone to that. And 4% of areas are going to get more than one of these in 30 years. So this 100-year terminology can be pretty misleading because it's actually at any given spot. Again, it's fairly rare, but if you look over a long period of time, you're probably going to see a big rainstorm like this somewhere near you, if not at your specific house or your specific farm or whatever. So what does this actually look like in real data? I made the dots, the X is a little bit bigger here. These are hopefully a little easier to see. These are 100-year rainstorms in Colorado from a 15-year period, 2002 to 2016. Where have they occurred? Some of these are probably going to be familiar. They're colored by month, so this dark blue is September. Here's all the 2013 flood rainfalls in here. So that's probably one that looks familiar. There's maybe some others that look familiar. This was May of 2011 out on the Northeast Plains. You might be able to pick some other ones. But there's some other weird ones in here. This pink color in December was a rainstorm in December in the western mountains where it wasn't snow, it was rain, and 2 to 3 inches of rain. But probably we don't think it caused a lot of flooding. We don't have a lot of records of flooding from that storm. So, which brings up the point is you can get big rains without big floods. You can have big floods from rains that maybe aren't so unusual. The 2013 flood was sort of the confluence of all of these things in the same spot. You had heavy rain that lasted a long time in steep canyons and places that are prone to flooding. But if that same rainfall occurred somewhere else, it may not be nearly as big of an issue. And even that huge rain in September of 2013, it didn't cause a 100-year flood everywhere. That depends on flood management, on how the infrastructure is designed and so forth, things that we maybe do have a bit of control over. There's that 2013 event. Okay, so what can we expect from this in the future? Well, so as the climate keeps warming, we're going to have issues related to the warm conditions. But in general, if we have more warm periods, we may see periods with more moisture in the atmosphere. So there's at least the potential for these big rainstorms. But as we talked about earlier, the moisture is only one ingredient. So it's hard to say for sure what's going to happen there. We could have increased moisture, but if we can't lift it in the right place or whatever, then we may not get the heavy rain out of it. Most indications sort of globally indicate that we're going to see heavy rainstorms more commonly. But again, for Colorado, we haven't really seen that yet, and so that part of it isn't super clear. But if we think about this issue, even kind of considering these uncertainties, we know what kind of rainstorms we can get in Colorado already. And do we feel prepared for that? Brian talked a lot about, are we prepared for a big drought? Same question is here. Are we prepared for another big flood in Colorado? I think in some ways we've made huge advances in this, right? The big Thompson storm in 1976 killed 130 some people. The 2013 flood in September only killed 8 or 9, and so clearly we've made some advances here, but I don't think we'd say we've got this problem solved yet either. And then, that got flipped sideways for some reason, but it's related to what we heard about this morning, right? We add 2 to 3 million more people, and most of them along the Front Range that's flood prone. We're going to see issues with this in the future that we need to think about. So here's some things that are going on to try and look at this problem. There's a lot of stuff on here that don't worry about the details, but there's a very cool group that is across public state agencies, federal government, Corps of Engineers, the private sector, to try and come up with better estimates of what the frequency of heavy rains actually is now in Colorado and whether it might change in the future. There's not a lot of sort of concrete results yet, but coming forward, that group is going to have a report coming out this summer. We're making big advances in forecasting. Heavy rain is really, really hard to predict, and so it might be one of those things where you feel like we're not doing very well there, and that is true to an extent, but we're also so much better at it than we used to be, and there's some really exciting things coming down the road, both in terms of forecasting the rain and forecasting the floods that can come out of it. Brian already covered this, so I'm not going to repeat what he said, but I sort of feel the same way. The spring is the La Nina conditions, although they're weakening, and we're probably not looking at at least what we can see now is not a good indication for a wet spring. If anything, the outlooks seem to point to dry, especially in the southern part of the state. Okay, so let me talk for just a couple more minutes about some exciting things we're doing at the Climate Center to try and get some of that data that Brian was talking about that you all can use to help in your decision making. Many of you are probably familiar with our COAGMET network. Many of you support that network. We greatly appreciate that. We're doing some great things with kind of from Nolan's inspiration and what Zach is working on with the network. You can now look at a map across the state of all these weather stations. There's 75 of them. You can see they're primarily located in agricultural areas, the Arkansas Valley, the Northeast Plains. I've covered up some of them out here on the West Slope. You can click on the map, it'll show you the current temperature. This is from last week, not from today, but if you went to the website, you could see what it was doing today. You can get long-term records at many of the stations. You can get 5-minute data, which is amazing. You can see those variations of the ups and the downs. And so this is the kind of data that can be useful for irrigation planning, for many other water-related things. And we want to really work with the water community to make this data more useful, more usable. So if you have suggestions on that, please let us know. And we really want to continue to enhance this network going forward. And then I can't take over for Nolan in this position without asking this question at the end of the talk. Do you have a rain gauge? Nolan founded the CocoRaHS Network. It is many thousands of people strong, just taking simple observations in their yard or in their field. So sign up for the network, cocorahs.org. Zach is has a table out there with an example COAGMET station, so you can see what one of those looks like, and also some rain gauges. And we always need more observers to look at what's going on in the rain. It's just,
Somebody in this room must sign up today.
yeah, exactly. And don't worry, I won't shame you as much as Nolan might if you get a gauge and take observations for a year and then back away from it. But I'll still probably shame you a little bit going forward because we need that data. And just as one example, it's not Colorado specific, but you can see where all the observers are nationwide. But look at all these really detailed rainfall measurements down in Texas during Harvey. This data is critical for the National Weather Service, for other groups that are trying to understand how much rain fell in this storm. And these are some huge amounts, of 25 inches of rain in one day. And then add that, they had that day for 3 days in a row, essentially, with over 50 inches of rain in some of these areas. But these measurements that people are taking, and in this case, their homes are flooding and they're still going out, dumping out the gauge because it's overflowing, putting it back out there and continuing to collect the data. Very dedicated observers, and this data is crucial for the kind of work that we do. So I appreciate the opportunity to be here. Here's our website, my contact info, and our staff at the Climate Center comes up with all sorts of great Colorado weather and climate tidbits that we can't share all with you in this setting, but we post them on Facebook and Twitter every day, and so you'll learn, if you follow us there, you'll learn some stuff about the fascinating weather and climate of our state. So thanks again.
Doug, do we have time for any questions?
We've got time for one question.
All right.
It's got to be a really good one.
Oh no, there's a really good one right
the
in the
bar is
front.
high.
Let's hear it.
Hang on.
And as former state climatologist, I can direct this.
This question's for Nolan.
See what you did?
So what atmospheric forces causes anticyclonic and cyclonic movement, and what initiates it and makes it turn the way it turns?
The Coriolis force. Because the Earth rotates, air when it moves, it always gets turned to its side, and we end up high pressure areas rotate in a clockwise fashion, low areas in a counterclockwise fashion. It's all because of the Earth's rotation. Yay.
Nolan, will the friction of the atmosphere slow down the rotation of the Earth such that days become longer and we can get more done?
Ever so slowly.
Any other questions? All right, I think that's it. Thanks. Oh, wait, not so fast.
Are you doing any work on the 100-year drought cycle that we're probably now in?
I can slightly address that. We last updated our statewide drought summary in about 2000, just during the 1999 wet years, and we had done a complete aggressive study of the drought history up to that time, but we didn't do a paleo drought. We were only really looking at observed drought during the instrumental records. So paleo, there's no doubt that we've had longer droughts from tree rings in the past 30-year, sometimes even longer than that in duration. Not every year, but
Well, the 5,000-year record would indicate that somebody ought to be looking at the 100-year drought potential and planning for the worst and hoping for the best. I don't know anybody that's doing that.
yeah, we've put so much energy into the observed record, and some energy, and some of your utilities have helped pay for some of the paleo tree ring studies to try to get a better handle on the long term. Yeah, there's more that can be learned from that paleo record. There's no doubt.
I think it's also a testament to who your audience is when you're talking about that kind of thing too. So I was in Lubbock, Texas yesterday speaking to the Texas Alliance of Water Conservation, and they are extremely receptive to that type of a thing, and for good reason, because they had the worst one-year drought on record back in 2011 for them. And as far as the economic structure is concerned of Texas, it crippled a lot of folks. I mean, you're talking fifth-generation ranchers that it put completely out of business because I don't think there was a lot of knowledge in, you kind of know how drought is created, you kind of know some of the forces that are, but so many people are just looking well at the past 150 years. So you can search online, and some stuff that I've been doing through what's called a drought atlas. And you can look at paleo drought, and you can look at these tree rings, and you're going to get a broad image of what has happened in the past. Can you project that going forward? I mean, I don't know. I don't know if you can or not, because things have changed. It's like 1978 through, 1999? We didn't have to worry about water in Colorado. That Pacific changes, all of a sudden we have to worry about water in Colorado. Not only for amounts, but we also have more people using more water. So, I mean, it's something that I'm looking at. Do I understand it? And how can we use it projecting forward? I mean, I've got a pretty good guess, but it's all about who's going to listen to you too. And obviously you're in tune with that. So it's important to you. See what I'm saying? Some people will just shun it. Like I said, you guys have no idea what's happening 3 hours from now. Well, you look at a tree ring and you know that drought that they've just witnessed in California, in the grand scheme of things, that was just a little blip. There have been droughts that lasted 200 years in those areas. But do those get talked about? Not necessarily. You know, it really depends on who's using that information and who your audience is, who's receptive to it.
Thanks. We're done.
Okay, thank you. Thanks again, Nolan.